Hello scholars. So today we're going to solve trig equations for when the b value is greater than 1. So you guys have solved trig equations. We've solved them by hand using the unit circle, and you've learned how to solve them using the calculator, where you use the inverse sine and the inverse cosine and the inverse tangent function. And then we had to do some work to find additional solutions. But let's lead into this a little bit. So when we take a look at a problem like this, that the sine of x equals root 3 over 2 over the interval 0 to 2 pi, what I want to do is, we know how to do this by hand, but let's just think about what the graphs look like for a second. So if I were to graph the sine of x, that's the green curve there, and the red line represents y equals root 3 over 2, we can see that what we have here is two intersection points. Now, we know from our knowledge of the unit circle that sine of x is going to equal root 3 over 2 in both the first and second quadrants, and that shows up on the graph, just to the right and left of pi over 2. We can see those two solutions. So that was with a b value of 1, but what happens when I change the b value to 3? So I'm going to think about the sine of x equals root 3 over 2, and to find these solutions graphically, if I take a look, if I were to graph the sine of 3x, we can see from this that looking at the green curve that we actually have 3 full cycles of the sine function between 0 and 2 pi. And when that happens, what we can see is we now get 6 intersections or 6 solutions to this. So when we look at a function like y equals sine of bx, and the b value, we know the b value determines the period of the function, we're used to getting things that look like this, right? That if I have the y equals the sine of x, the period is just 2 pi. But when I get to the sine of 2x, the period now becomes pi. And when it's the sine of 3x, we get a period of 2 pi over 3, or 4x, we get pi over 2. And what this shows us is that if the sine or cosine function has a b value of 2 and thus a period of pi, when we graph, we get 2 full cycles of the graph in the interval 0 to 2 pi. And also, if a sine or cosine function has a b value of 3, we get a period of 2 pi over 3. And when we graph, we get 3 full cycles of the graph in that interval. And the same is true with 4, and so on and so on. So in general terms, what I want you to think about is that in addition to being able to use sine and cosine to determine the period of that function, it also informs us how many full cycles of the function we graph over the interval 0 to 2 pi. So if the b value is 2, we get 2 full cycles. If the b value is 3, we get 3 full cycles, and so on. If you're thinking ahead about what about a b value of 2/3 or a value of pi over 6, the concept holds true, but we'll get to those. So let's go ahead and talk about solving. So here's example 1. I have, how am I going to solve sine of 2x equals 1/2 over the interval 0 to 2 pi? So if I take a quick observation here, I can see that the b value is 2. Therefore, there are 2 full cycles would graph over the interval 0 to 2 pi. So I find this a little hard to do. So what I'm going to do is I'm going to make the problem a little more familiar. So I'm going to let theta equal 2x. So then this problem, if I replace 2x with theta, I get this. I get sine of theta equals 1/2, and I know that from my knowledge of the unit circle. So what I've got to do is to account for the fact that there are multiple solutions in here. There's more than 2. And so to accommodate that v value of 2, I'm going to add 2 pi to each of those answers. So this is what I get. There's the original answers of pi over 6 and 5 pi over 6. But now when I add 2 pi to each of those, I get 13 pi over 6 and 17 pi over 6. Now to finally solve and get my answers, now I have to go back and sub back in 2x for theta. So if I replace theta in the previous line with 2x, I get that I know 2x is equal to these 4 answers. So now when I divide by 2, here I get my 4 answers: pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Now just to help us understand this a little bit, we can see that we now have 4 solutions all in the interval 0 to 2 pi. So our process here is we're going to make a substitution, solve for what we know, and then we have to add on to account for that horizontal shrink of the graph. Let's look at one more. Oh, one last thing, a quick observation here. So we have these 4 answers. So when we were given this problem to solve, we know that the period of this function is 2 pi over b, and our b value is 2. So the period is pi. So if we notice, the distance between the first and third solution is pi. When I go from pi over 12 to 13 pi over 12, that distance is pi, which is the period. And if I do the same with the second and fourth, so the distance between 5 pi over 12 and 17 pi over 12, that distance is pi. So we can see that these ideas still hold. That symmetry, that periodicity of the trig function still holds. All right, let's go on and what happens now when we up the ante a little bit, and now we have cosine of 3x. So again, the b value is 3, therefore 3 full cycles would graph over the interval 0 to 2 pi. So we're going to let theta equal 3x, and we're going to do our substitution and solve for this. So the sine of theta equals -1/2. So I'm going to get 2 pi over 3 and 4 pi over 3. Now because the b value is 3, I'm going to anticipate 6 total solutions. So to get those, I'm going to add 2 pi to each of these answers twice. So let's take a look at this. We're going to follow the blue line. So we can see that one of our original answers was 2 pi over 3. So I'm going to add 6 pi over 3, and I get to 8 pi over 3. Then I'm going to add another 6 pi over 3 to 8 pi over 3, and I get to 14 pi over 3. When I go back now to 4 pi over 3, one of my original answers, I'm going to follow the green line. And if I take 4 pi over 3 and add 2 pi, I get to 10 pi over 3. When I add 2 pi to 10 pi over 3, I get to 16 pi over 3. So you have to take into account what that b value is and how many potential answers you're looking for. So now I'm going to sub back in 3x for theta. So I get 3x is equal to those 6 answers that I had above. But to solve for x, I have to divide by 3. So I've got 2 pi over 9, 4 pi over 9, 8 pi over 9, 10 pi over 9, 14 pi over 9, and 16 pi over 9. And we can see all 6 solutions are in the interval 0 to 2 pi. All right, let's play with our calculator. All right, so now here things will get a little bit more awkward, but they're not too bad. We've wrestled with this kind of beast before. So if I take a look, again, that observation, the b value is 2, therefore 2 full cycles would graph over the interval. So now I'm going to expect a total of 4 answers out of this. So the first thing I'm going to do is I'm going to let theta equal 2x. And then I've got to go through the process of solving on my calculator. So I have the sine of theta equals -0.88. So I'll take the arc sine of both sides. The arc sine and the sine will cancel. So that's going to leave me theta equals the arc sine of -0.88. And from my calculator, I got -1.076. Now we had to go through this process, and I realized that so between 0 and 2 pi, there's no room in that interval for a negative value. So we have to go ahead and find our 2 solutions between 0 and 2 pi. So there should be one in quadrant 3 and one in quadrant 4 because we're dealing with a negative sign value here, a negative. And so just like we did before, we're going to use this value to find the appropriate angle in the interval. So one of those angles is 2 pi minus 1.076. And the other is pi plus 1.076. So I get these 2 values, 4.218 and 5.207. So just like we did before, now I'm going to have to take those 2 answers, and I'm going to add 2 pi to each of those. So I took the 4.218, and when I added 2 pi, I got the 10.501 number. And then when I took 5.207, I got the 11.490 number. All right, so that's good for theta, but I need to solve for x, and theta is equal to 2x. So I'm going to sub in the 2x for theta. So I just brought those 4 answers down, replace theta with 2x, and when I divide by 2, I now get these 4 answers. And just like we saw before, we can see that we have 4 solutions in the interval from 0 to 6.283. I know this seems like a little bit of work, but I'm sure you guys can get the hang of it. So go ahead and proceed to the Go formative and complete today's closer. Thank you.